On myself, Professor T.M. Divakar, working as assistant professor in Sharad Institute of Technology, College of Engineering. So today we are going to cover the loop analysis or the mesh analysis in a network analysis. So in the previous video we studied about the Cramer's rule, how to calculate the determinants. So based on that we are going to solve some problems in the loop analysis, and that Cramer's rule plays very important role. So let us see. So what is loop analysis or mesh analysis, and what is the difference between the KVL and loop analysis? We'll see. So loop analysis or mesh analysis. So this method of analyzing is especially useful for the circuit where there are many nodes or loops in a circuit. When the circuit is more complex, so by using loop analysis we can easily solve the circuit, or we can analyze that circuit. So most of the applications are based on Kirchhoff's laws and loop analysis. So what exactly the difference between the Kirchhoff's laws and the voltage law? Kirchhoff's laws and the loop analysis. So in a loop analysis, so instead of using the branch current, the loop currents are considered for writing the equations, and in the Kirchhoff's law only the branch current is considered. Already we know that what is the branch current and what is the loop current. And in the second difference is that each branch of the network may carry more than one current, and the total current must be decided by the algebraic sum of all the currents through that branch. So while in analysis using the Kirchhoff's laws, each branch carries only one current. The advantages of this method is that complex network, the number of unknowns reduces, which greatly simplifies the calculation work. Okay, once again in simple form I will tell you what is the difference between the loop analysis and the Kirchhoff's laws. The first difference is that in loop analysis the loop currents are used for writing the equation instead of branch current. The second difference is that each branch of the network may carry more than one current, and that the total branch current must be decided by the algebraic sum of all the currents through that branch. In Kirchhoff's laws, each branch it carries only one current. Okay, next point. So let us consider the network. This is the network. There are two loops. See here, already I explained what is the loop. A, B, C, D, E, F, A. This is the network. In that there are two loops, means A, B, E, F, A. This is one loop. Second loop is B, C, D, E, B. This is the second loop. And these two loops carries the two currents. Already we have shown here. The I1 is a one loop current, I2 is another loop current. The loop current I1 flows through loop 1, that is A, B, E, F, A, and loop current I2 flows in loop 2, that is B, C, D, E, B. Okay, so here we are assuming not it is I1 and I2 is not fixed for that loop, so we are assuming that two loops I1 and I2. Okay, so important key point is that while assuming the loop current, consider the loop, means we have to consider such loop that each element of the network will be included at least once in any of the loop. Means every element of the network should be covered any one of the loop. So you can consider such loop. Okay, see here once again I am telling you. So R1 is the element, R2 is another element. Here V1 and V2, these are the voltage sources. Okay, R3 is another element. See, now the branch B carries two currents. Okay, means I1 from B to E and I2 from E to B. So net current through branch B will be I1 minus I2, and the corresponding voltage drop across R3 must be as shown in figure. Okay, see here we have shown here two different cases, because the in branch R3 there are two currents, one is from loop 1 and second is from loop 2. In the first diagram, see here the arrow mark that is going from B to E, from positive to negative. So the total current is I1 minus I2. In the second diagram, it is shown that the arrow mark is going from positive to negative, means E to B, and that's why the total current is I2 minus I1. Okay, let us come to the diagram. So this is the diagram, this is the main circuit diagram. See, the element R1, in that element R1 only I1 is flowing, means the branch AB there is only one current I1 is flowing, but in branch B, so BE, that is the terminal, that is the element R3. Okay, the branch B, in that branch there are two currents flowing. See here, one is I1 current which is flowing from B to E. The direction of I1 is, look at here, I1, and in the same branch, that is B, another current I2 is also flowing. So already we know that if there are two different currents are flowing, then the total current is the algebraic sum of that currents which is flowing in that branch. So algebraic current means what? I1 plus I2. While considering the loop, the next point, consider loop. Okay, here we are solving the equations. Okay, so consider loop A, B, E, F, A. It is a one loop. Okay, so branch B, see, first we have to consider the polarities. Okay, the voltage, there are voltage, the voltage source, there are voltage, the polarity is already given, plus, minus. See, either you can go with clockwise direction or anti-clockwise directions, and you should consider the direction of the polarity, or the polarity is positive negative in one directions. Means for R1, you assume the directions positive negative, same for R3, positive negative, and current is flowing in the clockwise directions. Okay, see, so for branch B, the polarities of the voltage drop will be, see here, B for positive and E for negative. It is for current I1, and already we know that in branch B there are two currents flowing, another one is the I2. See here, and for I2, E3 is positive and B is a negative. So these are the polarities of the voltage drop while considering I1 and I2. Now, while writing the loop equations, assume the main loop current as a positive and remaining loop current must be treated as a negative for the common branches. Okay, so let us write the loop equations. See here, for loop A, B, E, F and A. Okay, see here we just put the polarities minus I1 into R1. Okay, next one is minus I1 into R3. Next term is positive here. Why it is positive? Because the current I2 is flowing from E to B and the polarity of the voltage drop is from positive to negative. So that's why it is a I2 into R3, and fourth term is a plus V1. Why it is plus V1? Because the current is flowing from negative to positive. See, we must have to consider the polarities, as the current is flowing from negative to positive means the polarity of that element or voltage source must be positive. And suppose if the current is flowing from positive to negative, the polarity must be negative. And for loop B, okay, let us come to the diagram. See, now here we have to write the equations. So for loop B, that is a B, C, D, E and B. So how we have to write this one? See here, in this loop I2 current is flowing through the element R2, R3 and voltage source V. Also I1 is also flowing through the R3. So let us calculate the equations. Minus, put minus sign. See here, you always consider that is the current is I2 flowing through positive to negative. Okay, so minus I2 into R2. Next one, see here, minus I2 into R2 minus V2. Why it is minus V2? Because the current is flowing from positive to negative. V2 minus I2 into R3, and see here the positive sign is given here, I1, because in the branch R3, in branch B, the I1 is flowing from B to E, that's why it is a positive, is equals to 0. So we got two different equations, and by solving the above two equations simultaneously, we can find out the unknown branch current I1 and I2. So let us see one example. Before that, you just remember the points, how to calculate or how to analyze the loop analysis. First one, while assuming the loop current, make sure that at least one loop current links with every element. Already we have discussed, means in simple form, in every element there should be at least one current, that is a loop current. Second point is, no two loops should be identical. Means suppose if you have given loop, if you have given I1 for loop 1, consider another loop, means there should not be two loops identical. So choose minimum number of loop currents, means you consider the minimum number of loops, so that minimum number of loops will automatically reduced. Convert if there exists a current source, then you can convert that current source into equivalent voltage source for loop analysis whenever possible. And next point, if the current in a particular branch is required, then try to choose the loop current in such a way that only one loop current links with that branch. Okay, so these are the main points. Let us come to the problem example. See here, you just observe this problem very carefully. For the circuit shown in figure, this is a circuit and we have to find the current through 30 ohm resistance using the mesh analysis. So where there is 30 ohm resistance, it is showing here, this is the 30 ohm resistance and we have to find out the current through that resistance. Okay, so before that we have to consider the loop currents. Okay, in the second figure we have considered the loops and the polarities of the elements. See here, the 100 volt, there is a voltage source. Next point, there is a 50 ohm resistance, so we have considered the polarities positive, negative. See here, the second resistance is 20 ohm resistance. Again we have considered the polarities positive, negative. You go in a clockwise directions and make the polarities positive, negative, positive, negative. Okay, so there are three loops are considered. Okay, one I1, second one is the I2 and third one is the I3. Okay, in the second loop I2 is flowing, so through resistors 5 ohm, the polarities, you can just consider the polarities positive, negative. Again in across 30 ohm resistance, positive, negative. Second one is the 20 ohm resistance, the polar. So for the element 20 ohm resistance, there are two currents flowing, one is I1 and another one is I2. So there are different polarities for across the 20 ohm resistance, it is for a different current. For I1 it is from positive, negative, and for I2 it is from positive to negative. Just look the directions it is going. Okay, in the next, again 5 ohm resistance, you can just consider the polarities positive, negative. Next, 100 ohm voltage source is there, and here also the same case. Across the 30 ohm resistance there are two currents, I2 and I3, which is flowing through this 30 ohm resistance. Okay, and the polarities are different for different current, means for I2 is different and for I3 is different. Okay, so let us solve this problem. Okay, so for a given circuit we have mentioned the polarities as well as we have mentioned the loop currents I1, I2 and I3. Okay, so apply the KVL to the various loops. So we have to apply the KVL's law to the loop. So there are three loops, means there will be three different equations, simultaneous equations will be considered, not considered, three equations will generate. So for loop 1 you just apply the KVL law. See here, minus. Why the minus? Because the voltage drop is from positive to negative, so negative signs will become, so 15 into I1. Next, 20 ohm resistance. See here, minus sign we have put because the polarities are from positive to negative, voltage drop from positive to negative, so minus 20 I1. See here, positive sign is given because the current I2 is also flowing through the resistance 20 ohm resistance, and that voltage drop is from positive to negative, so it is different. So that's why it is a positive sign, 20 into I2 plus, see here, first voltage drop, this is the current is flowing I1, the current I1 is flowing from negative to positive, the voltage drop is, so voltage drop is from positive to negative, so positive sign will become here. So therefore, see here, you can just solve this loop 1 equation, that is minus 15 I1 minus 20 I1, that is a 35 I1. Okay, here minus 20 I2 is equals to 100. Simply by taking the mathematics we have solved this, and finally it comes 35 I1 minus 20 I2 is equals to 100. Next, apply the KVL to the second loop. See here, minus 5 I2. Why it is minus 5 I2? Because the current I2 is flowing through resistance 5 ohm, minus 30 I2. Next, plus, see here, plus why it is plus 30 I3? Because the current I3 is also flowing through the resistance 30 ohm. So plus 30 I3 and minus 20 I2 plus 20 I1. Okay, so by simplifying we get, see here, 20 I1 minus 55 I2 plus 30 I3. Okay, so applying KVL to the loop 3. So see here, for loop 3 you can just apply KVL, minus 5 I3. So I3 current flowing through 5 ohm is minus 5 I3, minus 100 ohm minus 30 I3 plus 30 I2. See here, because in 30 ohm resistance the I2 is also flowing, so that comes positive sign. So after solving this, it comes 30 I2 minus 35 I3 is equals to 100 ohm. Okay, so there are three different equations we get by solving the loop analysis using the KVLs. Okay, so how to solve the equations and to find out the current through 30 ohm resistance. See here, the current through, actually for the example, for this example we need to find out the current through 30 ohm resistance. Means we have to find out the I2 current is also flowing through 30 ohm resistance, means we have to find out I2. Also I3 is flowing through the 30 ohm resistance, so we have to find out I2 and I3 also. So how to find out these unknown currents I1, I2 and I3? So by using the Cramer's rule we can solve these, or we can find out I1, I2 and I3. See here, so determinant D. So there is a Cramer's rule. So what Cramer's rule is saying, if the network is complex, the number of equations or the number of unknown increases. So in such case, the solution of simultaneous equations can be obtained by Cramer's rule. Okay, so D means it is a system determinant, or you can also it is you can say it as a D, that is a system determinant, and there are some general formulas to calculate the system determinants you can consider. Okay, for this example, in the previous video we studied about how to calculate the system determinants by the Cramer's rule. Also the subdeterminants we can find out by using the Cramer's rule. Okay, so you can apply here the Cramer's rule here. See, the total system determinants is what? D. Okay, so D is nothing but D is equals to in the first row, see, observe the in the first row 35 minus 20 and 2 0, it comes from the first equation, that is the C here, coefficient of I1 is 35, coefficient of I2 is a minus 20, and see here there is no I3, third element is 0, so 0 is given here. Okay, see here second row for system determinant D. Okay, 20 minus 55 and 30. See here, the coefficient of I1 is 20, the coefficient of I2 is minus 55, and coefficient of I3 is 30. And in the third row Okay, just observe here, there is no I1 here. So okay, I1 is 0, the coefficient of I2 is 30 and the coefficient of I3 is minus 35. So total system determinant is 21,875. Okay, so this is the total determinant. Now we are going to calculate the subdeterminant D2 and D3. Okay, so for this case we need to consider, see here, for subdeterminant, so we have to replace the column, the dash column of delta by the column of constant existing on the right hand side of the equations. Okay, so what are the constants here? So D2 means it is for loop 2. See here, observe the column number 2 in D2, in 100, 0, 100. So these are the constants as we got in the loop 1, loop 2 and loop 3. Just see, in loop 1 100 is the constant which is on the right hand side. Next for loop 2 0 is the constant which is available on the right hand side, and loop 3 there is 100. So we have to replace this column with the constant which is available on the right hand side. Okay, so in this system determinant we have to replace the second column with the constants here, and you can calculate D2. Same for D3, we have to replace third column with the constant. Okay, see here, 100, 0, 0, 100, 0, 100, and you can calculate the D3. So as sub determinant we got. Okay, so this is the steps to calculate the unknown I2 and I3. So I2 is equals to D2 upon D1, as we calculated D2 and D. So that is equals to minus 35,000 upon the 21,875. These values we have considered from the previous calculated, that is D is here, see here, D is 21,875, D2 is minus 35,000. So dividing this we got I2 is equals to minus 1.6 ampere. Similarly we can find out I3 is equals to D3 upon D. So minus 92,500 upon the 21,875, that it is I3 comes from minus 4.22 ampere. Now we have to calculate the current through 30 ohm resistance. Means this is the algebraic sum of I2 and I3. Why? Because the current I2 is flowing through 30 ohm resistance, as well as I3 is also flowing through 30 ohm resistance. So see here, I2 minus I3 means minus 1.6 minus of the minus. So total current through the 30 ohm resistance is 2.62 ampere. Okay, see here, as I2 minus I1 is a positive, means the current flows in the assumed direction of I2. Okay, thank you.